one more time with some of these higher powers. I do see a fourth power in here, so we will have a multiplicity 4, and that's not actually a big deal. An x to the fourth looks a lot like an x squared, so it's still just going to be a bounce. But I wanted to make sure that I got a chance to mention that. If you ever saw a fifth power, it would be very similar to a cubed. And you won't see a ton of that. At some point, it just gets kind of silly and making it tedious. But I do want you to know that that's what would happen if you had a higher power on one of your factors. Okay, let's look at degree. If I started multiplying this out, I'd get a negative x out of the first. The biggest power in the second would be an x to the fourth. In the third one, I get a 5x cubed. So that's a 125x cubed if you get rid of the parentheses. So I'm seeing 1 plus 4 plus 3. That's an 8th degree polynomial. And my global behavior is going to be a y equals negative x to the 8. Or if you want to get the constant in there, it would be a negative 125 if you actually cube that 5. So there's my global behavior. For local, I guess I don't really have to write that. I need to find my zeros and their multiplicity. And again, in factored form, the zeros become very easy, hopefully. Looking at factor number 1, if x equals 4, the entire thing will be 0. That's multiplicity 1. Looking at factor number 2, if x equals negative 20, the whole thing will be 0. And that one has multiplicity 4. And then last, if x is equal to positive 7/5, everything will be equal to 0. And that has multiplicity 3. So again, if you have any concerns at all that you're going to make mistakes with this, just set up the equation and you can solve. 5x would have to equal 7, and then divide x equals 7/5. Even if you get it, but you find yourself making mistakes, just write this out. I'll see people mess up the sign or get 5 7s instead of 7/5. And I know all of you can do this, so it's just sometimes stumbling with it when you're not paying super close attention. So if in doubt, just write the steps out to double check yourself. Maybe a good strategy while you're testing, just to make sure you don't make one of those silly mistakes. Okay, so that's my local behavior. So let's go ahead and draw some axes. And we need a fairly big scale here. We need to go at least to negative 20. So let's go negative 10, 20, 30. And I'll do the same on the other side. It doesn't have to be perfectly centered, but if we're setting that to be our scale, we may as well this time. Negative 20, 0, 4, 0, and 7/5, 0. Oh, I hate it. 7/5, 0. I feel like I had terrible planning. We can do that, but that's going to be really close. 7/5 is just bigger than 1. It would end up right in here really close together, and that makes it really hard to show the behavior. I'm actually going to modify this one a little bit. I'll fix it on your worksheet. Let's make that a plus so that we can say it's negative 7/5 just to give ourselves a little more room. So it's negative 1 2/5. Again, not that it's not possible, but I try and give you things that are spread out in a way that you actually have room to draw some of the multiplicity and things like that. Okay, we decided our global behavior was an upside down x to the 8th. So we're going to start from negative infinity and we're going to end up at negative infinity. So start from negative infinity. First local piece of behavior is the intercept at negative 20. Because that has a multiplicity 4, a power of 4, we're going to bounce right off there. And the only difference between it being a fourth power versus a second power is it will stay a little flatter. It kind of squares out if you go and check technology. It'll stay a little flatter for a little longer. So nothing big that you need to show, but if you're curious, that's what I would say. And then we head down for a little bit, but we do have to turn back around and come up to our intercept at negative 7/5. And that one has multiplicity 3, so we will cross, but we'll do it in this funny way where there's an inflection point where it flattens out in the middle and the bend switches. And then we'll need to head up just a little bit because we've got to get back down here fairly quickly to cross straight through multiplicity 1 at x equals 4.